Hi, today is July 2nd, 2025, and today I'll be giving my summary of the research paper Distinguishing Working States by Palm Orientation. The purpose of this research paper is to propose a wrist-worn sensor-based system to identify working and non-working tasks by the direction of the palm. This would increase productivity and help with self-management for office workers. So in this research paper, a smartwatch with a sensor is attached to the wrist of a hand. The fingertip direction, so outward, is defined as the y-axis direction. Rightward is defined as the x-axis direction, and downward from the palm is defined as the z-axis direction. The roll angle is defined as the x-axis rotation angle. And the pitch angle is defined as the y-axis rotation angle. And the direction of the positive or negative um, angles is is defined using the right hand rule. So the sensor on the smartwatch um, is designed to gather three-axis accelerometer data. And then using this accelerometer data, the angle data is calculated. Then that is used to determine whether the palm is facing upwards or downwards. From previous experimentation, a threshold value of 85% is used to decide the palm's orientation. The palm orientation label is then 1 when the palm is facing upwards and 0 when the palm is facing downwards. So in total, there are 7 activities to classify in this experiment, 3 working and 4 not working activities. And those are typing, writing, attending online meetings, reading, using a smartphone, eating, and playing video games. The sampling rate of the sensors is 10 hertz, and the features for the classifiers are gathered from the mode value of the palm orientation label over a 10-second period and the z-axis acceleration values in that 10-second period. These two features are fed into three classifiers: random forest, naive Bayes, and logistic regression. And the classifier's goal is to classify the activity over that 10-second period. So for data collection, there are 2 subjects that participated in gathering the data. The first subject performed the, the 7 activities in a total of 9 hours in a fairly uncontrolled setting, while the second subject performed each activity for 2 minutes to establish the threshold for determining the palm orientation. Tenfold cross-validation and leave one person out cross-validation is used. So as for results, a confusion matrix of F1 values was used to evaluate the results, and it was found that all of the classifiers had, using the different methods of cross-validation, had an F1 value of over 0.8. It was also found that placing the smartwatch on the non-dominant hand yielded the best classification results. One innovation I found in this research paper was that the data was collected in a mostly uncontrolled setting. Sometimes in other research papers, where the purpose is to classify the activity or the sitting position, the subject, the data from the subjects is taken in a very controlled setting. And this would, so the subjects wouldn't be able to relax or perform an activity as they usually would, thus making the model um un thus making the model under generalized to like real life data. Additionally, another main innovation is that the paper used the angle data from an accelerometer to calculate the palm position, which was then used to calculate or like to classify the the activity being performed. And this was a pretty unique innovation. On the other hand, one major challenge I found was that there was not enough subjects for data collection. There were only two subjects, and only one of them performed the activities for a long time in a fairly uncontrolled setting. The This model, therefore, is too undergeneralized, considering that the subjects may have had peculiarities or may have performed activities differently than others. For example, many people may have different hand positions when they read a book or have different postures when they attend an online meeting or use a smartphone. And since there are only two participants for data collection, um, there is not there's not enough of a range or variety of different methods for performing the activities. Additionally, there are also not enough variety of activities to classify. In the experiment, only 7 activities were named for classification, and was everything else belonged to the other category and was not classified. However, in real life, people do many more activities other than just the 7 ones named, such as using the restroom or standing up and walking, and these activities still need to be classified as working or not working. Finally, this is not really a challenge so much as an unclear detail, but it was not made very clear how the threshold for classifying palm orientation works. But overall, that's my summary for this research paper. And